We're going to look at reactions to form the alkynes, and what we're going to find is they're very similar to the reactions that form the alkenes. So in many ways this is going to be easier to learn than you did when you learned the reactions for the alkenes. To form the alkynes, we do it through dehydrohalogenation. Dehydrohalogenation, if you remember from last semester, is the removal of, let's say, hydrobromic acid or hydrochloric acid. And if we do that from a vinylic halide, that will form an alkyne. What is a vinylic halide? A vinylic halide is an alkene that has either chlorine or bromine on the carbon-carbon double bond, on one of the carbons in there. You can also do a double dehydrohalogenation of vicinal or geminal dihalides. So a vicinal dihalide is where you have two halogens on carbons adjacent to each other. A geminal dihalide has the two halogens on the same carbon. And by removing two hydrobromic acids or two hydrochloric acids, you actually then form the alkyne. Note that it is through a vinylic halide intermediate. So basically you're forming it from the vinylic halides. How can you make the dihalides? Well, you can form a 1,2 dihalide by just doing halogenation of an alkene. So if you have an alkene, let's say you add bromine across the double bond, and then you can treat with 2 potassium hydroxide, and then it forms an alkyne. So we'll look at that in just a little bit. So here is an example of dehydrohalogenation of a vinyl halide. Notice it is an alkene with a halogen on the carbon-carbon double bond. If you treat this with potassium hydroxide, what do we get? We get an alkyne. Notice this is a terminal alkene, and we end up with a terminal alkyne. Here we have a dihalide, and as a result we have to use 2 potassium hydroxide to remove 2 hydrochloric acid. And what do we form here is another terminal alkyne. What's shown here, this right down here, is that you can get this by treating an alkene with a halogen, and if the halogen adds across the double bond, you get a 1,2 dihalide, and then treating it with potassium hydroxide gives us the alkene. Here are some examples of how you can form alkynes by dehydrohalogenation. Here we're taking vicinal dihalide and treating it with 2 potassium hydroxide. And here we're taking a geminal dihalide and treating it with 2 potassium hydroxide. With the treatment of the base, what happens is you will form the alkyne. Here we're forming a terminal alkyne. Here we're forming an internal alkyne. Here are some problems for you to try. What halides would you use to make these alkynes, and what alkenes could be used to make the halides? Go ahead and pause the lecture, try the problems, and then restart it. Okay, well, we see this is a terminal alkyne. We could use any of these halides right here. We could use a vicinal dihalide. We could use either of these geminal dihalides, although this one may give us an internal alkyne. Right here, if we treat this with 2 potassium hydroxide, we would form the terminal alkyne. If you wanted to use a stronger base like sodium amide, you would find, because sodium amide will deprotonate a terminal alkyne, you'd have to use 3 there. But potassium hydroxide would effectively remove the two hydrobromic acids. What alkene would this come from? Well, we can take this alkene and treat it with bromine, and it will add across the double bond like this. Okay, how do we make this alkyne? Well, the most common way would be to use a vicinal dihalide, or and to make this vicinal dihalide, we can use this alkene. Always remember that an alkene can be converted to an alkyne by halogenation to the dihalide and then double elimination with base. So this is kind of like that when you see that you're going to an alkyne, always remember that you can go to the alkyne from a dihalide, and from the dihalide you can get the dihalide from an alkene. Other functional groups can lead to alkynes also, because alcohols can be converted to alkenes. We've learned how to do that, and we'll see some examples and problems in the soon. Alkenes, which can give us alkynes, and halides can give us alkenes, which then can give us alkynes. So how can you prepare one hexyne from one hexanol? Try to do this and then restart the lecture. Okay, so how can you prepare one hexyne from one hexanol? Well, the one hexanol can be converted to an alkene. And so I can take the one hexanol and treat it with phosphorus oxychloride, and that will give us the alkene. Treatment of the alkene with a halogen, such as bromine, will give us a 1,2 dihalide. The 1,2 dihalide can then undergo double dehydrohalogenation to give you the terminal alkyne. To make ethynyl benzene from styrene, again, we say the same thing. The alkene can be converted to a dihalide, which then can undergo dehydrohalogenation. So this is what would happen. First thing, you could halogenate it, add chlorine across double bond, and then do dehydrohalogenation to give you the alkyne. So what is the outcome of this reaction? Okay, if we see, we've got sodium amide, which is a very strong base, and we have a vinylic halide. If we treat that with the strong base, what ends up happening is we get a triple bond in there. Why, though, are there two sodium amides? Look at that compound and try to figure out why there might be two sodium amides. Of course, if only one was used, the most acidic proton on that molecule would be removed, and the proton removed that's most acidic would be on the alcohol. So you have to use two, one to remove the proton first, and then one to remove the hydrohalic acid.